to first give the introduction on the uh, iteration and the conditional operations. Then the iterative operations are bifurcated into these types of loop. First one is the do loop, which is again divided into these three loops: do loop, do while loop, and the do until loop. Then the for loop, then comes the nested loops. Then we'll also discuss the control flow statements, that is iter and the leaf opcode. Then we'll also get to learn about the infinite loops, and also we'll discuss about the tips to prevent them as well. Then we have conditional operations as well, which is bifurcated into if statement, else if, and the select statement. Then we'll be having Q&A, and anyone can ask the questions that you may have. So let's get started with the introduction. First one is the iteration statements. These are commonly known as the loops, which allows us to repeat a block of code multiple times, making it easier to handle repetitive tasks and the process collections of the data. Whether we are looping through the records in a file or iterating over arrays. So mastering iteration enhances our the code efficiency and the readability as well. Now comes the conditional statements. These are known as the decision-making statements that enables decision-making within our program with the constructs like if, else if, and the select. We can control the flow of our execution based on a certain set of conditions, allowing for the dynamic and the responsive applications. So throughout this session, we will provide practical examples and demonstrate how to implement these operations effectively in our RBGLE programs. So by the end, we will be having a solid understanding of how to utilize these conditional and the iteration logic to create the robust application. So let's get started with our first iterative operation, that is do. So in RPGLE, we use the do and undo structure to create the loops for the for repeating a block of code. Let's just say for a specific number of times, it can be 5, 10, 20 number of times. So this do loop takes the argument such as starting counter, maximum value, and the index value. We can see the syntax which is in the fixed format. In the factor one, we can take the starting counter. At the opcode, we can give the loop name, that is do. In the factor two, we can give the maximum value, and in the result field, we can give the current index value. If we are specifying the factor one and the factor two, then it can be the variables with the 0 decimal positions. Also, if factor one and the factor two is not specified, then the default value is taken as 1. So let's take a look on the example. So this is the first example for the do opcode. Here I have declared one variable counter to track the to keep track of our iterations, and this has been initialized to 1. And if we are not initializing it with 1, then by default it will be taken as 1. Then this is the factor one. At the factor one, we have taken the starting limit, starting value, and this is the factor two where we have given the maximum limit, that is 10. And at the result field, we have taken the index variable. And then we are going to display the value of the index for the 10 number of times, because the maximum limit is set to 10. And inside the loop, we can do any processing we need, but here we are just displaying the value of the current index. And the loop will going to continue until and unless the counter exceeds its maximum limit. So let's just call this program to check its output. So it is going to display the value of the index till 10. I have another example for the do opcode. Here we have seen that well, the do loop is mainly used when we want to repeat a block of code for a number of times. So we haven't declared any increment factor, but what if we have to use the increment factor? So we can define it at the factor 2 of the end do opcode. So that means this loop is going to execute 5 number of times with the increment value as 2. So it is going to display from 1 to 10, but but the odd numbers, as we are incrementing it by 2. Now we have another example as well. I have explained in the slide that if we are defining our factor 1 and the factor 2, then it should be with the 0 decimal positions. So here I am declaring this counter variable but initializing it with the decimal positions. So when I'm trying to compile this program, this is going to throw an error. So let's just compile it. So it is giving an error, and which is of severity 30. So let's just check the spool file. We can go to the bottom and then let's just check with this message ID. So here it is saying that the field is not defined as numeric with 0 decimal positions. So that means when we are defining the factor 1 and the factor 2, it is necessary, or we can say it is mandatory, that it should be with 0 decimal positions. So if we define this variable as with 0 decimal positions, then it is going to compile. Okay, it is still saying. Okay, we have defined here with the 1 decimal position. That's why it's throwing an error. So now it is being compiled. Now let's take a look on the other type of loop, which is do while loop. So it's a fundamental control structure in RPGLE, which is used to execute a block of code repeatedly as long as the condition remains true. So that means this loop is going to execute as long as our condition remains true, and we can specify the looping condition in the factor 2. And there is one other way to use the do while loop, that we can use it with the comparator XX, and at the factor 1 and at the factor 2 we can give the comparant, and XX denotes the comparator, which can be GT greater than, LT for less than, EQ for equal to, NE not equal to, GE greater than or equal to, and LE less than or equal to. And this do while loop is known as the entry control loop, because the looping condition is checked before any iteration takes place. Means it is checked at the beginning. If the condition is not met, it won't enter into the loop even for a single time, and the control will be passed to the statements following the end do opcode. Now the example of the do while opcode. So here I have declared a variable index of numeric type of length 2, and here this is the do while loop, which is going to execute until and unless our index is less than 20. So first it is going to check the condition. If the condition is true, then it is going to process the statements which is written inside this do while loop. So here we haven't initialized any value to the index variable. So by default, it will be taken as 0. So it is going to check the condition that 0 is less than 20. Condition will become true, and it is going to display the value of the index. Then the index is being incremented by 5. Then it will become 0 plus 5 will become 5. Then again, it is going to check the condition. 5 is less than 20. The condition becomes true. And then again, it is going to display the value of the index. And then again, it will be incremented by 5. So this goes on until our index is less than 20. So it when it becomes 10, again it is going to check the condition that becomes true. Then for 15, and once the index become 20, then it is going to check for the condition that 20 is less than 20, condition becomes false. So the control will be passed to the statements which is written after the end do. So now it is going to display end of the loop. So let's just call this program. First it has displayed 0, then 5, 10, 15, and then when the index become 20, the condition will become false and it will come out of the loop and displaying end of the loop. We have another example for the do while opcode, where we have used the comparator, which is GT, for comparing the index and the 20. So here the index variable has been initialized with 20, and first it is going to check the condition that 20 is greater than 20. The condition becomes false and it will directly come out of the loop. That means it has not entered into the loop even for a single time, and once the condition will become true, then it is going to enter into the loop. So when I'll be calling this program, so it will only display end of the loop. We have another example for the do while opcode. Here I have written this program in the free format. This index variable has been initialized with the 5, and again it is going to check the condition that 5 is less than 20. The condition becomes true and it is going to display the value of the index, and then again it is going to increment the value of the index by 5. Then index will become 10. 10 is less than 20, condition becomes true. Then it index will become 15. Again it is going to display the index. Then index will become 20. Is 20 less than 20, condition becomes false, and then it will come out of the loop. So it has displayed 5, 10, 15, and end of the loop. Next up we have do until opcode. So do until op loop is a fundamental control structure in RPGLE, which is used to which is used to execute a block of code repeatedly as long as the condition remains false. That means it is the opposite of our do while opcode. The do while opcode is going to execute as long as our conditions remains true, and in case of do until opcode, it is going to execute as long as our condition remains false. And the looping condition we can specify at the factor 2, and we can also use the do until opcode with the XX comparator, which can be the same which we have learned in the do while opcode. And one more thing regarding do until opcode, that the do until loop is guaranteed to be executed at least once, because the looping condition is checked at the end of the iteration. First it is going to enter into the loop, then it is going to check the condition. That's why this is known as the exit control loop. Let's take a look on this example. Let's just understand this example in debug mode. So here I have declared the variable index, and which has been initialized to 30. So first it is going to enter into the loop, then it is going to check the condition. So F10, as we can see, it has gone to the statements which is written inside it, and it is going to display the value of the index. Then index will be evaluated by incrementing it to 5. The value of the index, we can see it becomes 35. Now it is going to check for the condition. So 35 is greater than 20. The condition becomes true, and now it will come out of the loop, as this do until opcode executes when as long as the condition remains false. So now the control will be passed on to these statements, which is written after the end do opcode, and it is going to display that end of the loop. And now it has set the last indicator record on. So let's just check the output once again. So first it has displayed 30, and then it is going to display end of the loop. Next up, we have the do until opcode with the comparator. Here I have used the GT comparator greater than, and then going to this index variable has been initialized with 10, then going to execute these statements. Then it will display the value of the index, that means 10, and then index is being incremented by 2. It will become 12. Now it is going to check for the condition that 12 is greater than 20, condition becomes false. So it will enter into the loop as the condition is false. So it is going to display 12, then it will become 14. 14 is greater than 20, condition becomes false. Then again, index will be incremented by 2, it will become 16, 18, then it will become 20. So 20 is greater than 20. Again, the condition becomes false. Then it will display the value of the index and evaluate the index by incrementing it to, it will become 22. So is 22 greater than 20? Now the condition becomes true. As soon as the condition becomes true, the flow will be, the control will be passed on to the statement, which is written after the end loop. So it will display end of the loop. First, it is going to display 10, 12, 14, 16, 18, 20, and then it will display end of the loop. The same program I have written in the free format as well. Here the index has been declared as 30. Now it is going to check for the condition. First it is going to display the, first it is going to execute the statements which is written inside it. Then it is going to check for the condition. So it will first display 30 and then index will become 35. Now it is going to check the condition. 30 is greater than 20. Condition is true and it will come out of the loop. So now next up we have for loop. So before moving on to the next other type of loop, we have learned do while and the do until loop. But I would like to discuss the differences between the do while and the do until loop in RPGLE and why we typically prefer the do while loops over do until loop in our code. First, let's talk about the clarity. So this do while loop, as we know that this do while loop executes as long as the condition is true. This straightforward approach help us visualize the flow of the program. In contrast, whereas our do do until loop uh, runs until our condition is true, which can be confusing sometimes. So for instance, if we would say do this until the counter reaches 10, it's less clear when the loop will actually going to stop. Secondly, in case of do while loop, that it is commonly used across many programming languages because it's more familiar and it makes our code easier for others to read and the maintain. Thirdly, we can say that this do while loop aligns better with how we naturally think about loops. For example, if we want to repeat a task while a certain condition is true, then this do while loop fits perfectly. This clear intent help us to avoid any logical errors. Lastly, for the do while loops, it can prevent the mistakes because the condition for exiting a do while loop can be easily understood, but for the do until loop, it can be easily misunderstood, which can lead to infinite loop or any unintended behavior. So with do while, the exit condition is often easier to manage. So, in conclusion, both the loops are valid, but do while loop promotes better clarity, commonality, and ease of use, and also can be helpful in preventing errors, thus making it the preferred choice in the RPGLE. Now let's discuss the for loop in RPGLE. So it's this for loop functions similarly to a for loop in any other programming languages. So this for loop is a versatile control structure which is used for iterating over a range of values. Means this allows us to execute a block of code repeatedly based on a certain set of condition. It is commonly used when we want to like it is commonly used when we know how many times we are going to execute a block of code. That means number of the iterations are known. But in case of do while and do until, the number of iterations are not known. And this for loop takes the arguments such as index name, starting value, increment value or the decrement value, to and the down to clauses, and then the limit value. So this to clause is used when we are doing the forward iteration, and this down to is used for the backward iteration. So when we are specifying the starting value, increment value or decrement value or the limit value, these can be the numeric values or the expressions, but with the 0 decimal positions. If we are trying to give the decimal positions, then it will throw an error, which we have already seen in the do opcode as well. And if we are specifying the increment value, then it cannot be 0. And then we have by and to clauses. These can be specified in either order, which means like here by 2 to 99, like first we can either give the increment or the decrement factor, then the limit value. And it can be in a reverse order as well, that first we can give the maximum limit, and then we can define our increment or the decrement value. Now let's take a look on the for loop. So here, few variables have been declared. Here, this is the index name count, and our starting value will be 1. Then our maximum limit will be 10. And here I have not defined any increment factor. So it will be by default taken as 1. Then here I have also taken a input from the user, and I'm going to display the table of that number which we have entered till 10. So first it is going to multiply that number with the value of the count. So currently the count is 1, and let's just suppose if we have entered the number as 5, so 5 will be multiplied by 1, and then it is preparing the output like as it's a character variable. So here I'm typecasting it the numeric variable. Then here it is going to display 5, then the multiplication sign, then the value of the count, currently it's 1, then equals to, and then the result which has been multiplied here, means 5 into 1. Then it is going to display 5, and then it will display the value which is stored in the output. Then then the count will be increased by 1, which will become 2, and then again it will be 5 will be multiplied by 2, and then it will again prepare the output, and then it is going to display the output. So let's just call this program. Here I'm entering the number 5. Then it is going to display the table of 5 until and unless our count will be 10. Once the count will become 11, it will come out of the loop. Also, we have seen that here I haven't defined any increment factor. So it can be, we can also give the increment factor, and it can be specified in any way. First, either we can give the increment or the decrement factor, then the maximum limit, or we can first give the maximum limit, then we can define the by clause for the increment or the decrement factor. Next up, we have, if like as mentioned in the slide, that if we are specifying the increment factor, then it cannot be initialized to 0. So here I have initialized it with 0. Let's just check if it throws an error or not. So it is going to, so it is throwing an error of severity 20. Let's just check the spool file. So the increment value used in a for operation is not valid. So a 0 cannot be specified in case of increment factor. Apart from 0, we can specify anything. Also, we should specify the increment factor without with 0 decimal positions. So next up, we have another for example. Here I have displayed the value of the count in uh, the reverse manner. Like here for the backward iteration, we use the down to clause, and for the forward iteration, we use the to clause. So from 10 to 1, I am displaying the value of the count here. And the decrement factor has been used here as 2. So it is going to display the even number. So next up, we have this nested loops. Uh, so these nested loops allows us the complex iterations within iteration. Nested loop is simply a loop inside another loop. We use them when we want to handle more complex data like grids or the tables. So loops like whatever loops we have learned till now can be nested inside each other. uh, Here how it works. So for the nested loop, uh, if for each cycle of the outer loop, the inner loop runs completely based on its own condition. This means that the inner loop executes every time the outer loop goes through its process. For example, if the outer loop goes through the 3 iterations and the inner loop has 5 iterations, so the inner loop will run 5 times for each of those 3 iterations, resulting in a total of 15 executions. So the advantage of using nested loop is that they allows us to break down complex tasks into smaller and the manageable parts. But we have to be careful that too many nested loops can slow down our program and even and even increases the complexity of the program if it is deeply nested. So in summary, we can say that nested loops are helpful for working with the multi-dimensional data efficiently. So let's take a look on the nested loop example. Let's just first, here I have uh, displayed the pattern using the nested for loop. Let's just check the pattern first. So this is the pattern I have displayed with the help of the nested for loop. So here I have declared two variables, I and j. I is for the outer loop and j is for the inner loop. So we have to first understand the structure to form this pattern. We need two loops, an outer loop to control the number of the rows and inner loop to control the number of the asterisks which are going to be printed in each row. So our step 2 will be the outer loop will iterate from 1 to 5, representing the total number of rows, and each iteration of this loops corresponds to a new line in our pattern. Then the inner loop, then this inner loop is going to uh, uh, print the asterisks based on the current iteration of the outer loop. So for example, in the first iteration of the outer loop, we print 1 asterisk because the inner loop is going to execute from 1 to I, means 1 to 1, and that's why it is going to print only 1 asterisk. When in the second iteration, I will become 2, then the inner loop is going to execute from 1 to 2, resulting in um, printing the asterisk 2 times, and so on. It will go on until our I reaches 5. After the inner loop completes, then it is going to display. Here it is just preparing the result. So using nested loops, which allows us to create the complex patterns efficiently, and by controlling the iterations of the each loop, we can achieve the desired output. Now let's just call this program. So it has displayed accordingly. So you all can try experimenting with the different rows counts or the symbols to see how the pattern changes. Now we are going to learn about the control flow statements in RPGLE, that is iter and the leaf opcodes. They belong to a broader category of the opcodes that manage how a program executes the loops and the branches. Specifically, we can say that they are used in the context of the loops control. The iter operation, what it does, it transfers the control from within a do or the for group to the end do or the end for statement. So in simple words, we can say that the purpose of the iter is just used to skip the remaining code in the current loop iteration and move directly to the next iteration. It iter works well with the various types of loops which we have already learned. This do until with the comparator, do while, and do while with the comparator, and the for loops. It helps manages the control flow within the loops, which allows for the more dynamic and the conditional execution of the codes. Um, then we typically use iter when a certain condition is met and we want to bypass certain actions for that iteration. And also using iter, it improves the code's readability by clearly indicating that it is intentional, that we are skipping it and making the logic easier to follow. Also, it can enhance the performance by reducing unnecessary computations when our certain conditions are met. Then let's see the example. Let's understand it in the debug mode. So here I have declared one variable index, then use the do while loop, and it is going to execute when the index will less than 10, and then incrementing the value of the index. And if the index becomes 5, then I am skipping the remaining remaining logic and moving on to the next iteration. After that, displaying the value of the index. Once the loop has been evaluated, then we are displaying that end of the loop. Taking F10. So currently the value of the index is 1. That index is not equals to 5, so it is not going to enter into the if condition. Then it is going to display the value of the index. Now index becomes 2. Now in that 3 is less than 10. Then first it has checked the value of the index, 2 is less than 10, but now the value of the index has been increased, and it is going to check that if index is equals to the 5, but currently the value of the index is 3, so the condition is not met. Then it is going to display the value of the index. Then again it is going to check the value of the index. Index value has been increased. Currently the value of the index is 4. Now the 4 is less than 10, condition becomes true. Now index has been incremented by 1 and it will become 5. Now the condition becomes true and it will skip these logic which is returned. Now it will just directly, the control will be passed on to the end do, and it is going to iterate the next set of a statement. Now index will be less than 10, and it has incremented by 1, which will become 6. Now it is going to execute till 10 number of till 10. The value of the index is 8. Now let's just check the current value of the index is 10 right now, and 10 is less than 10. Condition becomes false. It will come out of the loop and will display that end of the loop, and it has uh, turned the last record indicator on. Now I have also another example of the iter where I have used it in the nested loop. So we have set up an outer loop which runs from the 1 to 3, and an inner loop from 1 to 5. Additionally, we are going to implement a condition which is going to skip the uh, inner loop when the inner loop variable becomes 3. So step 1 will be we'll create two loops, as we have discussed, that one outer loop for 1 to 3 and inner loop for 1 to 5. When I will become 3, then it will start the outer loop, which will iterate 3 times, representing the value of the 5. When for j equals to 1 to 5, this begins the inner loop, allowing for the 5 iterations for each value of j. And if j becomes 3, then it is going to check that if the current value of the j is 3, and if it is true, then then this keyword iter is going to skip the rest of the inner loop for that iteration. If j is not equals to 3, then we proceed to the display keyword, and then display opcode, which is going to display the current values of the both I and j. So let's just call this program. So for the outer loop 1, it is going to skip the 3. For the when I becomes 2, then it is again going to skip 3. And then for I equals to 3, it is again going to skip 3, as we have the condition when j becomes 3. Next is leave opcode. So the leave opcode basically transfer the control from within the do or the for group to the statement which is returned after the end do and the end for operations. So in simple words, we can say that the leave statement is used to exit a loop immediately, regardless of its condition. So we can use leave with any of the loops which we have covered till now, and it helps the control the flow of the program by exiting from the loops based on the specific conditions. It can used when we want to stop the processing within a loop when a certain condition is met. And using leave opcode, it can enhance the performance by preventing the unnecessary iterations once our condition is met, which can be especially useful in the large loops. Also, now let's just take a look on the example. So here, uh, we have used do while opcode, and it is going to execute when the index is less than 10. Then we are incrementing the value of the index, and if the index becomes 5, then it is going to leave the loop, and it won't execute the rest of the conditions. While in case of iter, it is just skipping that iteration and moving on to the next set of iteration. So when index will become 5, it is going to execute the statements which is written after the end do of code. So now let's just call this program. Okay, we are in debug mode. So it has displayed 1, 2, 3, 4, and when the index becomes 5, it has left the loop and the control was passed on to the statement which is written after the end do. Okay, we have one more example. The same which we have seen in the iter in case of nested loops as well. So here the same outer loop which iterates from 1 to 3 and the inner loop from 1 to 5. So when the inner loop becomes 3, it is going to leave the loop. So this leave opcodes only impacts the inner loop. It is not going to impact the outer loop. So let's just call this program. So inner loop is iterating from 1 to 5. So when j becomes 3, it is going to leave the inner loop. So it has left the inner loop. That's why it hasn't executed 4 and 5. When outer loop becomes 2, it is again going to display 1, 2 only. And for the 3, 1, 2. When j becomes 3, it has left the inner loop. And now we have reached end of the loop. Next up, we have the infinite loop. This is a crucial concept in our programming. We will explore what they are. I'll also provide the examples and will also discuss the potential problems and will go over the tips to prevent them. So what is a infinite loop? So infinite loop occurs when a loop is going to execute endlessly because its termination condition is never met. Uh, this can happen in any types of loop, do while, do until, and the for loops. So what happens if our loop goes infinite? There are several issues which we may face. First one is the system resource consumption. By that, what I mean that an infinite loop can consume CPU resources, making the program unresponsive and will potentially crash it or the system. Either it will crash the program or our system. Then next is memory leak. If our loop is going to continuously create the objects without releasing them, then it can lead to the memory exhaustion. Next up, we have the user experience. For the applications with the user interface, infinite loops can freeze our interface, which can lead to the frustration for the user. So it will be a very bad experience for the user if our loop goes into infinite. Then debugging difficulty. An infinite loop can complicate the debugging as it might prevent you from reaching the point where we can test or troubleshoot other parts of our code. So, what steps we can take to avoid the infinite loop? First up, we have set clear loop conditions. Means we can always ensure that the condition to exit the loop can always be reached. For example, we can make use of the variables that will eventually change its state. Second, increment or the decrement counters. If we are using any counter, make sure it is updated within the loop so the termination condition will eventually be met. Next is the add break statement. Using a break statement, if you detect a specific condition that should end the loop, like in case of leave, if we think that a certain set of condition is met, then we can make use of leave. So it will not execute the unnecessary uh, code which we have written. While infinite loops can be a powerful tool in programming, but they can also lead to significant issues if it is not handled properly. So, by following the best practices and the uh, being vigilant with our loop conditions, we can create more reliable and the efficient code. So, that's it for the iterative operation. Now, we can also take a look on the infinite loop program as well. I have created one loop. So here, this index variable has been declared with the has been initialized with the value 5. and we are checking that index is less than 20. So 5 is less than 20, the condition becomes true, and it is displaying the value of the index, and then we are decrementing the value of the index by 5. So 5 minus 5 will become 0, and then 0 is less than 20, condition becomes true. And then again, it is going to subtract the value of index. It is going to subtract the minus 5 from the value of the index. It will become 0 minus 5 will become minus 5. Then again, it is going to check the condition, minus 5 is less than 20. And as we know that the negative values is always lesser than the positive values. So in this way, it is going to, that means this loop is going to be infinite. That every time it is subtracting minus 5 from the negative value, and it will always be less than the 20, which leads to the infinite loop. Now we can call that. So now it is going to, when we are trying to hit enter, it is going to print the values endlessly. So what we can do to prevent, like to stop this infinite loop, we can press shift escape altogether, and then we can give 2 to stop this program. Now we have this conditional operation. First off, we have if opcode. So if statements in RPGLE, which is essential for the conditional logic in our program. That means it allows to execute a block of code based on whether a specified condition evaluates to true or false. So like in this example, we can see if date 1 is greater than date 2, then it is going to execute the set of these statements which is written inside this if and end if block. If the condition is not met, then it is not going to execute these statements which is written inside it. So let's take a look on the example. So here I am checking that here like I have a variable declared called score, and which has been set to 80. We want to determine the grade based on this score using separate if statements. So first we have checked if the score is greater than equals to 90. If it is greater than equals to 90, then the grade will be evaluated as A. Then if score is greater than or equals to 80 and 90, that means if it is between 80 and 90, then it will evaluate grade as B. If the score is between 70 and 80, then it will evaluate to C. And finally, if the score is less than 70, then the grade will be evaluated as F. And then I am displaying the score and then the grade. So for time being, the score has been initialized with 80. So it will goes into this condition and it is going to display the grade as B. Here I have used like multiple if conditions, but I would like to discuss the disadvantage as well of using multiple separate if conditions, and the benefits of incorporating else and the else if blocks as well. So while these separate if statements can be clear, but they have some drawbacks also. Like first, each statement is evaluated independently, which can be inefficient sometimes, especially with these many conditions. This may slow down our program. Additionally, we can say redundancy can occur, leading to the longer and the harder to maintain code. Also, it can increase the risk of the logical errors as well. Like in the same case, if this score has been initialized to 80. So first it is going to check this condition as well. Now this condition has been evaluated to true, but we have another if blocks as well. So it is going to execute these as well. It's just going to check the condition, which is actually not required here. That's why we have the if and the else if and the else blocks as well. which we are going to learn in the next slides. Next up, we have if XX. So this XX is again the comparators, which we have already seen in when we were learning about the loops. So a group of calculations can be carried out using this if XX operation, if factor 1 and the factor 2 have some relationship between them, can be denoted by this comparator. And this factor 1 and the factor 2 can be a literal, a named constant. This can be a figurative constant. This can be a data structure, field name, array name, and but these can be this factor 1 and factor 2 if we are defining it, so these can be of the same data types. And if uh, this if group has been started, then there should be an end if to close this if statement. If we are defining an else block, then it is not required to write this end if, but it can be written after the else block. So now let's take a look on the example. So here I have one variable num1 which has been evaluated to -4, and here I'm just checking whether the number is negative or not. So if the number is less than 0, so here LT is for less than. So if num1 is less than 0, then we are displaying that the number is the negative. So here the number is -4, the condition becomes true. That's why it has gone inside this if block and will be displaying that -4 is negative. So calling this program, and it has displayed -4 is negative. Then we have nested if as well. We'll check this program once we learn about the else block. So now this else statement in RPGLE, which enhances the functionality of the conditional logic. This else statement is used in conjunction with the if statement to provide an alternative block of code that execute when the if condition evaluates to false. So moreover, else ensures that all the possibilities that are accounted for, helping to avoid the missed cases. So in summary, incorporating these blocks leads to more efficient, clear, and the reliable code. Let's take a look on the else example. So here I have evaluated the num1 as 8. If it is less than 0, that means the number is the negative, and we are displaying that the number is negative. And if the number is not less than 0, that means that number is positive, and we are displaying that. So here I have taken the number as 8. So it is not less than 0. That's why it has goes into the else part and has displayed that number is positive. Next up, we have this else if statement in RPGLE, which again allows for the multiple conditions within the conditional logic. So this else if statement is also used in conjunction with the if statement, and to evaluate the additional conditions when the initial if condition evaluates to false. So the program evaluates each condition in the order. If a condition evaluates to true, then the corresponding block of code executes and the rest of the conditions are skipped. So suppose if this condition is false, then it is going to execute, going to check the condition which is returned with the this else if block. If that is not true, then it is going to check this one. If that is also not true, then it is going to execute this else part. So here I have declared these variables SP and CP, which here denotes the selling price and the cost price. Here SP has been evaluated to 1,000 and CP has been evaluated to 1,500. Then I am calculating the difference between them to evaluate whether it's a loss or the profit. Then SP minus CP means 1000 minus 1500, which will give minus 500. So it is a loss. So if result value is greater than 0, then it will be a profit. Then we are displaying the value of the profit. And if result is less than 0, then that means loss has been occurred and we are displaying the loss. And if if SP and CP is same, then the result will be evaluated as 0. That means no profit or loss. So in this case, loss has been occurred. That's why it has displayed minus 500. So next is the select statement in RPGLE, which provides a powerful way to handle the multiple conditional branches. So this select statement is used to execute a block of code based on the evaluation of the single expression, which is similar to the switch statement in any other programming language. So when the condition is being mentioned with the when or the when XX opcode, if no when or when XX condition is satisfied, then and if an other block is specified, if this when and when conditions are not met, then an other block is specified, then the control will be passed on to this the statements which is written after this other block. If no when XX or no other block is specified, then the control will be transferred to the statements which is written after the NDSL group. So in short, what select statement consists of? First of all, a select statement. Then we can have 0 or more when or when XX groups, and when we can have a optional other group, and then and NDSL or the end statement, denoting the end of the select statement. Okay. So for here, um, like in this example, I have taken an input from the user for the week number. Then here in this select block, I haven't declared any when or other block. So the control will be passed on to the statements which is written after the end SL. This we can understand by the debug mode. Let's just call this program. So it has first it is going to take the input from the user. Let's just enter 8. So the hence here no when or other block has been specified. So the control will be passed to this NDSL, and then these statements are going to be executed. Then it is going to display that no condition to execute. Next up, we have the same example, but here I have no when or when XX block declared here. Just an other block has been, an optional group has been declared here. So regardless of any week number we are giving, so the flow will be passed on to this other block, and it is going to display the invalid selection, even though if we are giving the valid week number. So if we are giving 5, then it is going to I guess I have called is displaying that no statements. Why? Let me just compile this program again, because here we are displaying invalid selection. Okay, let me just check that. Okay, so it is displaying that no elements, because no case has been matched. That's why it is displaying that. So then we have another example where I have declared these when blocks. First, it is taking up the week number. Then if the week number is equals to 1, then it is evaluating the weekday as Monday. If week number is 2, then it is evaluating to Tuesday, and till 7 it is evaluating the weekday as Sunday. And if we have entered any invalid week number, then it is going inside this other block and it is going to display invalid selection. And then at the end, it is going to display the weekday. So let's just call this program. Here I'm entering 2. So it has displays Tuesday. So okay. Next, will discuss if else if ladder versus select. So as we have seen that uh, the purpose of using if else if and the select are almost similar, then why we are preferring the select statement? Because select offers a more organized way to handle the multiple conditions. It handles complex checks without cluttering the data, unlike if multiple if conditions. Or in case of readability, the structure of the select makes it easier to read and understand when we have so many conditions. So select provides a clear flow, showing exactly what we are evaluating. Then comes up the performance. From a performance standpoint, select can be more efficient. It evaluates conditions in a single pass, while and if and else if ladder checks each condition sequentially, which can be slower with so many checks. Then the fall through capability. Select can allow for the fall through behavior if it is designed to do so, where multiple conditions can lead to the same block of code. And this can also simplify our logic. And finally, select can manage all scenarios effectively by using when other to cover any unmatched cases, ensuring we do not miss any important conditions. So, in summary, this select provides a clearer, more efficient and more structured approach to handle these multiple conditions, making it the preferred choice in many situations. So for the same example, if we have seen in the multiple if conditions as well, that if the condition becomes true even, uh, let's just open that program first. I guess which one is the program? Yes, this one. So here we have seen that if the condition becomes true, still it is going to check the rest of the conditions. But in case of select, uh, if the condition becomes true, then the control will be passed to the end SL, and then it is going to skip rest of the conditions. So let's just check in the debug mode. So score has been initialized with 80. So score has been initialized with 80 and it will check for the first condition, that is a score greater than equals to 90, condition becomes false. Now this condition is going to be true and if grade will be evaluated to B, and then it has skipped rest of the conditions and the control will be passed on to the end SL, and then it has displayed the score and the grade. That's why we prefer a select over else if ladder as well, and even multiple ifs as well. So that's all for today. Now I'm open up for the questions. Yes, for the do while loop, we can use it as the nested loop, just like we have used for the for loop. We have explained that in the slide as well, that nesting can be done with any of the loops. So nesting can be done with any of the loops. Then in RPGLE, when opcode is used like the switch case. Yes, in the switch case, we have case statements. So in like in the Java, we have learned that for the select statement, we have switch. And for the cases, we use here when opcode. Do we have any other questions? I guess there are no open questions anymore. So thank you everyone for joining this session.